Here we're asked to find the exact values of these compositions. So I have the inverse sine of 5/13 on the inside of a tangent function. So it's like I have to figure out what angle this is first, right? But I don't know what the inverse sine of 5/13 is. I don't know what angle that is. So what I'm going to do is I'm going to imagine drawing a little picture down here. Because every time I see an inverse trig function, I can think to myself, hey, that's an angle. And in fact, that's the angle where sine of that angle is 5/13. Well, sine's positive in the first quadrant, and so I can think of this as a right triangle. Draw my little angle theta, and then I have a 5/13, right? Sine's the opposite over the hypotenuse. Oh, we can find the missing side by using the Pythagorean theorem. 169 is equal to 25 plus a missing side squared. So we do a little subtraction, and I find out that that missing side has to be the square root of 144, or 12. Well, I'm looking for the tangent of that angle, right? This is tangent of sine inverse, which is what I'm calling theta, right? So I'm looking for the tangent of theta. I get the opposite over the adjacent, or 5/12. All right, we're going to do the same thing down here in number 2. All right, so again, I want to think about theta being that inverse trig function, because every time I see an inverse trig function, it's describing an angle to me. And again, we're dealing with an inverse sine here, so I have a 5/7, the opposite over the hypotenuse. And again, I can think about a missing side. And so I have 49 is equal to 25 plus that missing side squared. Take 25 away from both sides, and let's see, I have 24 is equal to the missing side squared. So I get the square root of 24, but because I'm not a monster, I will simplify under that radical. Let's see, that would be a 4 times a 6 under there, so 2√6. All right, I'm now looking for the cosine of that angle theta there, so I get the 2√6/7. All right, so those were 2 nice, happy problems. Let's just do one more that might make us think through things, I don't know, just a little more carefully. So let's say someone asked us find the cosine of the inverse tangent of -2/3. All right, so I think we see the extra little wrinkle here, right? That's not going to be a first quadrant angle. So I get theta is equal to the inverse tangent of -2/3. Tangent theta is equal to -2/3. All right, so right away I can tell you where theta is, because inverse tangent of theta has a range between -π and +π. Theta is a negative angle in quadrant 4. All right, well, all I really need to know is the quadrant 4 bit, because now that I know I'm in quadrant 4, I know that cosine is positive in quadrant 4. So now I don't need to worry about signs at all. I know what the sign of my final answer is. So instead of drawing a right triangle with this angle theta in it, I'm going to imagine that it's the reference angle. I could also draw a picture that looks like this, where I rotate down theta, right, because that's what theta is, and then draw a right triangle hanging down in the 4th quadrant, and actually use the signed diagram. But I'm just going to use a right triangle here, thinking about a reference angle. Tangent is the opposite over the adjacent, so 2/3. My hypotenuse is missing this time, and I find out that my hypotenuse has to have a length of the square root of 13. All right, so I'm looking for the cosine of that angle, so 3/√13. And I know my answer is supposed to be positive, because cosine is positive in quadrant 4, so that was settled for me at the very beginning. And some of you out there might really want to rationalize this denominator. So I'd multiply top and bottom by √13. And I could write that as 3√13/13. A nice, happy final answer.